Good evening to all. Today we are going to have a lecture on introductions to 3D visualizations and 3D GIS. So in this lecture we'll see that how the GIS is now progressing in 3D domain and how the 3D data can be integrated for different applications. So they may be for geological studies, there may be an urban related studies, they are also being used in disaster management. So we'll see a few applications at the end of this project, this lecture. So let's understand what exactly is the 3D data. So generally in 3D GIS we are concerned with the 3D data, and in this 3D data the most important informations which we see that or the basic characteristic of any 3D data is that it is voluminous, so it is very large, and the volume is very huge. So accordingly the size of those files are also very high. Then as well as there is a heterogeneity in data representations. 3D data also includes the time space. So it means there's a temporal variation at a particular place that is also required. And sometimes we are also having in a multi-variate data sets, or there's a large number of different attribute data which needs to be linked to these three data sets. So all these are actually the important part of our day-to-day activities, and generally in 3D GIS we are expected to integrate all those data sets. Generally, till now you might have come across all the representation of the GIS data sets which is planimetric in nature. So it means that you'll be having the data which will be only having an x and y coordinate, and there is a lack of z coordinates to those data sets. But in 3D GIS, we incorporate z coordinate. Along with that, there's a temporal variations that also gets integrated, and using that we create large animations and simulations based on temporal scale. So generally, 3D data sets are quite huge, and nowadays with the advent of uh, these the larger computer graphics workstations available at a consumer grade desktops, so these simulations are now becoming more and more popular. So let's see that how the 3D visualizations had started earlier. And in this case, we see that earlier, if you want to show any kind of 3D variations, the view state analysis is one of the way to represent it. Over here, you see that the view state analysis uh, algorithm has been applied on uh, basically the height information data, and then we are also combining that with the change in color. So the color or the hue is being used along with the visual analysis to give you an effect of 3D data. So generally, if you see, is that actual information is represented in 2D, and only the impact is being created that some places is at higher altitude, some places is at lower altitude, based on the view shed output along with the color table combinations. So this was the earlier approach, which was used in a different maps to represent the 3D informations. Along with that, we also come earlier we can have a lot of maps which will be having the different contour intervals, and these contour intervals will actually provide the height information. So over here, the variation in the height needs to be interpreted by the map reader, and in the case of viewshed analysis, there is an extension of uh, or the basically the visual color and the corresponding viewshed algorithms assists the map reader to interpret that these particular places is at higher altitude or at lower altitude. So this was the first representation of 3D map, which were actually in a planimetric maps, or which were in two-dimension paper. Later on, with the uses of different computer systems, the people started visualizing the data in 3D coordinates. So we are having an x and y coordinate which gives the locations. These xy coordinate can be a false easting or false northing, or it may be lat long values. Along with that, the additional Z informations was added. So over here, the Z information just gives you the height variations, and these variations can be considered basically as a value at a particular grid level or at a particular raster values, and that gets represented, and we see the impact of 3D effect. Later on, along with the height variations, which was physically possible, so the Z coordinate was being shown over here, and along with that, the attribute was shown in the in a color tone. So over here, the difference between these two is that over here we are seeing only the height information which is being included over here, but in this case, along with the height, we also see the attribute level of each grid. And and the same thing was later on applied in stereoscopic visualizations techniques, and then later on the 3D models were created, and then in combinations with the view shed analysis, people started creating a disparity map which gives started giving a kind of height variations in at a particular locations. So these were the slightly improvement in compared to the uh, earlier one, the map-based 3D visualizations. The difference was that the 3D over here in these actually can be perceived either based on the perspective projections, or it may be in form of stereoscopic uh, disparity maps. So these were combined, and then 2.5D representation of 3D data started. Then, with the help of two different perspective images, and those were combined for a whole scene. And then the NLGIF based systems started using. So people require a specific set of glasses, which will be red and blue glasses, and these glasses you might have seen it in different cinema halls, or we can also use a simple blue and red color films to perceive the 3D information available in this image. So generally the color differences based on the disparity or the height was used to give an effect of 3D data sets. And thus we say that this is actually a slight improvement, where we can see that where exactly is the changes in geospatial domain. Along with that, the perceived height or the relative height between different locations can also be seen. Only drawback in this representation was that the scale or the actual height was not possible to measure it on this data set itself. If you want to measure it, then you need to have a kind of scaling factor. Based on that, the height information or the disparity information can be extracted. So this is called 2.75D technologies. Then, with the help of the actual 3D information started coming in with the software, like in ArcGIS, where actual information in term of exact values or the coordinate systems linked together was started coming in. So in this case, we see the example of two different representation. One case is we see a simple extrusion, or the each polygon has been just extended or provided in height, and that gives the a kind of relative variation. So this 3D information just gives the representation of the data set, and it is not linked to actual height informations which is present on these geographical locations. So it's a kind of representation where we use the extrusion of different polygon just to show the attribute value of each of those polygons. So this is a vector representation in 3D maps. Similarly, the raster data set was also started coming, and that can be used for surface visualizations, and this is called DSM, or digital surface visualizations, where surface model is being built. So over here we see that X and Y coordinate and the Z coordinate on the top of surface is being shown with the colored which is changed, which has been used to represent the different heights. The actual 3D map has started coming, and if you ask for actual 3D maps, then you'll be able to see the plastic maps which is available from different providers, including Survey of India also provides a few uh, model-based representation of different places that can also be made available. So over here we see that there are different representation. One representation which is actually small scale, which just shows the surface, the how the basically the actual along with the terrain and the top of that different features, how this terrain features is changing. So this variation is being shown over here. So this actually a kind of small scale representation of data sets, and this data set is just showing the actual height variations and slight features details. But later on what has happened is that the people started creating a detailed model for each of those component on the surfaces, and these are the large scale representation of data sets. And in this case, we can see the each individuals and the corresponding architecture level details has started coming in. And now we are having a few data set which is available in a different at different scales. These data sets are available for different locations. So in this case, we see that the data set is actually built for each of those places, and if anyone wants to visualize these data sets, then in that case actually the perspective of the users or the camera locations or the viewing angle of different users can be changed. So if somebody wants to see it, let's say at particular azimuth and height, the information will be shown here. But if somebody wants to change that height or azimuth, then the same information will be represented in a completely different way on a viewport. So thus we see that in case of 3D map, we require a large amount of interactions. There is an way to change your viewing angles to particular locations, and that actually provides an advantage to see the informations not only at a one particular perspective projections or at a particular view, rather than we can view or visualize the information from the different angles, and that provides a lot of new interactive applications which have started coming for these 3D maps. So generally in these 3D maps, the way we defined different scales in GIS 2D datasets, instead of that, in 3D datasets we say something about the level of details. So those level of details are now is being defined in a different ways. Some of them are actually based on the geometrical information. So these are actually specifically for few applications like settlement and building. The Thamens has defined aggregation at statement or the basically a block level or at individual buildings or within a building a particular segment or a roof component. So accordingly we have different LODs. So in LOD 1 we see multiple building combined together, so that's the information will be visible to us. In LOD we can see the individual buildings details, and then third case is within the individual buildings again there will be multiple components, so that can be seen in these LOD details. So these were specifically defined for settlements and building. Later on, it got extended, and then we had another definitions of the details. Those are actually starting from the ground level information. So those actually people started saying LOD1. Then LOD1 is basically on the ground. We will see a texture. So this is LOD1 is also called a kind of gray level models. So which will just give the height informations. LOD1 will include the texture informations. So it means on the top of that we can do a wrapping of different satellite images, so that provides the LOD2 informations. Then we provide only the envelope of the surfaces in terms of convex hulls. So those are actually called the LOD3. And LOD4, we go to individual buildings, and within those buildings, each of the surfaces, so that first front or the back or the top of the roofs may have different texture or pictures associated with that. So those started coming in LOD3, and in LOD4 we go at exactly at the architecture levels where see we can move in inside an building, and we can see the individual component like chair, tables, and so on, whichever may be those the information may be present within the building. So we see that there's a large variation of the scales or the informations which is possible in 3D data sets, and these are being defined based on the sensor data which is available along with the semantic consistency, so that there is a building. Inside the building there will be a lot of rooms. Within the rooms there will be a lot of sub different things like chair and so on. So based on those semantic relationship was also included in these representations. So these were basically starting from build surface to the details inside a building, and these two are actually we can say is widely used for large scale city visualization cases. Then in case of terrain models, we have LOD0, so this information gives the orthophoto and wrapped on the top of basically classified images, and those information is being represented over here in LOD0, which has been defined by Grogel and et al. And then we are seeing that there are then additional information which has started coming, which was LOD1 as in case of Netflix con. So same information that popping off, and then adding it to the texture or roof level, then architecture model which has started coming in LOD3, and LOD4 we are seeing indoor detail architecture level. So on that sense, if you see that these two uh, cases or the definitions of LODs are more or less similar, and people are now starting defining or trying to get a consolidated different LODs for different applications, and these LODs becomes a kind of important factor to determine the cost and effort required to build 3D data sets. For example, if we go for LOD01 dataset, then probably we need a terrain and ortho rectified images of those places. Where in case of LOD1 and 2, we also need the detailed information of the buildings or the footprint present at different locations. So thus we can see that this difference between the data sets is being brought on using these LOD definitions, and these LODs actually then gets links to the effort and time required for carrying out or generating any 3D data sets. So there might be a questions that why do we need 3D GIS? So 3D GIS, as earlier we have seen that in daily uses or in the daily day-to-day life, we see that everything is in 3D world. So we need to have the information which is easily perceivable, and that informations we need to represent it in a GIS platforms, and that's how the 3D GIS has born. So over here we see that in 3D GIS, basically, if we want to carry out a kind of complex analysis where we need to uh, carry out a large scale impact of the cases like the urban flooding. So there will be a different house present at different city levels, and if there is any flooding happens at a particular place, then which all area or which all houses or at what floor the water level will be available. Is the water spread in a particular city happens at once, or it happens, at a different stage level. So those kind of simulations can be carried out, and those becomes an important factor for disaster related management. Then the as we know that the data sets or information we look for is on earth is basically not in 2D, so we need to do carry out anyway the informations which is present in 3D. 3D GIS also has a very important factor, that is the interactivity. So if you want to see any features, you do not have to stick to the view which representer wants to show you. If you see that any maps which is being created, so those are will be an orthographic projection. So it means that those the maps are considered to be completely in orthographic projections. So it is like viewing or seeing the features exactly from the top of that features. But if you want to see it less the same feature at a perspective of, or maybe at the viewing angle of 60-degree or from the ground, so the view and the information what you see will completely change. So that information is not being represented or captured in 3D, in 2D or 2.5D data sets. So but in case of 3 data sets, there is a flexibility for interactions, so users can do or change a perspective view based on the data sets, and then they can see it from the north direction, from the south directions, and if as the direction changes, the orientation of complete data sets gets changed, and the informations will give different pictures about a particular features. And the other thing which these interaction brings in, that at a different scale we'll be seeing a different information. So let's say if you are visualizing the same city at a height of 2000 meter or 1000 meters, so it will be seen the information which is seen at a city levels, where you'll see, okay, a few cluster of houses, few green covers and so on. But as you come down or as you zoom in, you will start seeing the detailed information of data sets like individual colonies, the roads, and so on. So 3D GIS provides the capabilities to do an interaction with the geospatial data sets at a different scales simultaneously. And this brings the complexity, that you are having a data sets which looks different at different scales. So it means like if you want to build a 3D GIS data sets, you need to create multiple LODs data sets. We have to enable the information that at what scale which information should be visible, and all these has to be provided in a real time, because user is yeah, doing an interaction using a simple mouse or touch screen based interfaces. So if you see that the 3D GIS has now started coming in different applications, and it has variety of applications which is being seen, and there are a lot of case studies available on this. Few of you might have seen the 3D GIS applications in architectures or in basically the geological analysis, especially in petroleum explorations and so on. And then there is also an the underground water supply, or the utility mapping management cases. So people have been using the 3D GIS uh, data sets in those areas. But now, as the three data sets are getting richer and richer, and we are having a different sensors which provides very detailed information like lidars, or the capability of software like Google SketchUps and so on, which provides the capabilities to create a detailed level of architecture model for individuals area. The 3D GIS application has started sipping into ecological studies, large scale urban planning. Then there's also an environmental assessment impact. In case of disaster mitigation planning, there's the 3D GIS is being used. You might have also come across the few of the navigation applications where we can see the different paths, and the corresponding 3D informations can be shown as we navigate along with the on-site map, which gives the position of the vehicle. So, and this has now started coming in different vehicle segments, and that is now getting in huge interactions, and then also it is also having in consumer level grade information is also being now put in. So there's a large amount of three data sets information is available, and these there are few applications and the gadgets is being built in case of 3D navigations as well. So in case of 3D data sets, the one of the applications which we can see is that creation of large scale 3D city model data sets. So under that we create a simple 3D base layer. So these 3D base layers actually has the infrastructure details like each of those building informations, road network, pipeline. So whatever features which we think is important for our simulations, those data sets gets created. And once we create, and this is actually a very time consuming process. Most of the time, if the people who are using or a 3D GIS for large scale simulations, they create at only the gray models, or the model which will only having the height informations and its geographical locations. They don't provide the large scale architecture level, or the texture information on all these walls. Basically, these data sets are being used as a base layer to do a lot of analysis like disaster modeling and so on. In some cases, people have used these applications or these 3D models to provide a very large scale landscape visualization. So this techniques is being used by the real estate developers to give you the kind of view of any new colonized building and how it will look like uh, as a whole, and what will be the trees and different amenities where it will be available and so on. So user can see those information at from any perspective, and then they can also do a measurement and try to get an assessment that how the actual lands or the locations will look like if he is going or living at that places. So that there actually the landscape visualization is being used in case of 3D GIS. So this is basically a visualization part. Then there's an also a large scale change deductions. So if you use a kind of lidar data sets where one survey is being carried out, and we have a surface model created for at a particular locations, then we can do a kind of change detection at a different T1 and T2, and based on that we can see that which all the places which is having changes or the redevelopment has been done at a particular places. So such things is being can be seen, and they can be used for visualizing and as well as doing an assessment that is there development is happening only at a particular location, or the development of a city or area is at as a large, or it is equally happening at different places. So we see that the way we can see the different change detection applications in 3D and 2D domain. The 3D GIS also provides you the kind of 3D change deductions, and based on that we can carry out similar kind of studies and interpretations as we do the two time scales change detections. We are also having kind of economical models where we can see the each buildings and corresponding land use of those buildings, and based on that we can expect that what kind of and how much revenue are the people living at that locations and they can provide. People have also started using such models for doing tax collection and assessment, because if the large scale survey is being carried out, then exact surface area or the actual carpet area of any building can be determined. And as you are aware that the municipal corporations or any taxation agencies collects the uh, household or municipal taxes based on the per square feet or carpet area. So based on that, the revenue leakage can also be tracked in, and it's possible to create a large scale data sets to identify which are the areas which is underestimated or overestimated. So such economical models getting links to large scale taxation systems and so on. Then there are now other applications are coming in, like if you're having a large scale cities and if you want to find out the actual solar potential of any city. That means that if somebody installs or if a particular municipal corporation decides that we are going to provide a solar panel to each and every household at an on subsidized cost, then in those cases we need to see that after installing the different solar panels, how much is the maximum energy which can be generated on a different rooftops. So for that, the assessment analysis, we can do it based on such 3D data sets. In case of urban 3D modeling or the disaster management, basically we can see we can do a simulation at city levels, household, road. If any water gets uh, and waterlogs started at a particular locations, then we can easily see that with the time bound how the rain or water is basically getting logged, and which are the area which is getting first inundated or impacted, and which are the area which is not getting impacted by the flooding situations. So those were actually the few applications which is possible after building and base 3 data sets and slowly adding it to the different physics level simulations or the landscape based detail architecture details. So we have seen those applications. Those were actually a kind of simulations and uh, uh, analysis which was being carried out at the back by the particular individuals or a group of people. But with the advent of new technologies, especially in case of browser technologies or the HTML5 technologies, now it's possible that anyone who is seeing the 3D maps, they can also query those informations, query the information of those data sets directly. So that brings the kind of interactivity to these 3 data sets. So we'll have large scale 3D data sets, and based on those 3 data sets, if somebody wants to just see the, okay, if this is my house and if I want to see what is the estimated area, so by clicking on that we can give detailed attribute informations about that particular building, and that can be shown, and the corresponding informations can be shared with house owners or between the different agencies. That's also a possibility is there for doing an interactive attribute query. So it's like same kind of query which we do it in 2D GIS, where we do vector or raster based attribute query, and similar kind of query we can do it now for at the individual 3D building levels. Then in these cases, if you want to see that only the houses which was more than or in more than a particular values based on the attribute, so the kind of attribute filtering is possible, and based on that we can visualize the whole information. In this case, we see that we are having a filter data set which is showing all the height of the buildings which is on a different classes. So in majority of these classes, we see that the height of the building is in between 10 to 25 meters, and such kind of interactions can be created. And once such interaction is being done, then we can see the lot of patterns emerging out of it. In this case, as we see that as the attribute information has been uh, or the attribute based on the height has been carried out, so we see that there's a large cluster of information or the houses of similar categories is being available at a particular locations. So if you bring out such classifications and do a large scale application of those data sets, then we can come up with a lot of theories. Like in this case, the smaller houses are available at the periphery, where in the larger area, the carpet area houses are actually at the center of the cities, and there's a clear demarcation of those kind of houses can be seen. And this brings the applications especially related to the different geospatial simulations. It's a kind of linking the informations from spatial domains to different pattern recognition techniques, and based on that we can bring out very good interactions and the corresponding theories of how the cities interacts, or the different component of cities interacts with each other. The fourth is, so these in these three cases we see that in one case that attribute query we deal with a particular layer, then we started doing a filtering, then we see that there's a spatial distribution based on classification. So all the three data sets here actually we are having is that it gives the snapshot of the three data sets at a particular time. But if we combine such a snapshot in a temporal scale, then we'll have large scale temporal informations which can be combined, and then we see temporal animations. In this case, as we see that if any dam breach happens at these locations, so based on the flow of the water, we can find out at which all areas will get inundated at what time, and that gives the kind of assessment that if any dam breach happens, so how much time is available at the downstream to get attention to it. So accordingly we can plan any kind of disaster mitigation planning has to be done, so those things can be carried out. And this shows the potential of 3D GIS and spatial temporal data applications in case of extend that is basically an extension of 3D GIS. So if somebody wants to build a 3D GIS data sets and do a large scale uh, uh, planning for creating 3 data sets for a particular locations, so generally the people will be having a kind of base map there at a particular areas or a footprint which is available at, let's say, 1:1000 or 1:5000. In some cases we may be having a layout plan of a particular area even at 1:500 scales. So those layout area plan can be taken as one of the input, then we need to attach the different height informations, and these height informations can come from different 3 data collection techniques. So those may be a lidar based or a photogrammetry based approach, where we can combine multiple few photographs to get uh, a kind of view where we can see each of those segments of the buildings and how does it's getting distributed in a particular space that can be generated. And based on the analysis, we can find out what is the average height of this building if we are looking for an average height at a particular as a building levels, or there may be the sub component like one block of a building and another block of the buildings, and accordingly the average height can be computed. So these heights can be integrated with your base data, which will which gets combined. So it gives an attribute to your the footprint of the different buildings, and then we can combine it with the DTM. Excuse me. So we can combine these attribute information or surface information if you're having a terrain models either in DM or DSM for data sets, and these can be combined to give the actual terrain variations which is possible at a different footprint locations. And once we are having different features or the polygons or the buildings polygon or footprint, uh, and then we also have an height informations, then these data sets can be combined in a 3D geospatial data storage, where or we can also do an external attributing if you're having like say the different uh, walls photographs, so those can be combined together to create a textured map of those areas can be created. And once we have a detailed 3D information or the gray level data set for each building along with the texture informations and the distribution of different utility and height of the streets and the location of those streets, how much street it is taking. So combination of those data sets can be used to create a large scale 3D GIS data sets. And then these data sets can be used for either visualizations or the landscape visualizations can be done for the same data sets, or we can carry out a few analysis. So these two are actually the usage or application of whatever 3 data sets which we create. Then those are being consumed by the visualization process or analysis process to give you a kind of overview of particular area. So this is just an example of how if somebody wants to create a 3D GIS data sets, so what are the ways they can use or what are the ways to extract those information from existing 2D data sets. So once we say that we can do the 3D analysis of these 3 data sets, so let's see that what are those analysis or the spatial query which is possible. So earlier we have seen the cases where the attribute based query was possible, or the classification which was completely related to a specific feature and its attribute. Now along base not only the basis of their attribute informations, we can create the different kind of analysis. For example, the buffer analysis. So if you want to see, let's say that within a sphere, if any sphere is being created at a particular location, so what are all buildings will be falling inside those spheres. These are the just two examples where it is creating at one places, or this is taking care of with the surface of the earth surface is also being created. So it means like there's a compensation for the earth surface is being adjusted over here. Now these buffer analysis can be used for the applications like impact analysis of any explosion. So if any explosion happens at a particular floor of a tower or at the bottom of a tower, then which all areas or which all building will get impacted by that explosion. So such kind of analysis or the applications uh, can be built using these 3D buffer analysis. In this case, we are also seeing in this case we are also seeing that if any explosion happens, so it's possible to find out which all the buildings will get impacted, and these inputs may be useful for different agencies who is providing the services for doing an disaster management or security related analysis. So they can use such analysis, detailed analysis using 3D buffer analysis. There's an also a possibility of building, creating the same extension of this 3D buffer analysis by bringing the material level details for interactions. So if any explosion happens at a ground surface level and we want to see that which all buildings will have a higher impact of or which portion of the building will have major impact, which will not be impacted. And this explosion is being created, this scenarios is being generated based on the type of material for which is being used or the strength of material which has been used for different building creations. So accordingly, the impact of that explosion will be different. It will not be uniform as it is being seen over here. So the impact or explosion will no longer in isometric cases. It will be a kind of different directions. There will be a different forces which may be possible, and corresponding the impact will be at different for at different locations. So such kind of analysis can be carried out, and then we can carry out the kind of height of a building, so that easily can be determined. We can also get an information that what is the total surface area of particular building. Now there may be questions that where will these kind of applications will be useful. Now these kind of applications or the kind of area volume estimations may be useful for planning. Let's say if somebody decides that the whole city has to be painted in a different color, then in those cases we need to know what will be the approximate cost. So if you know the per square feet area cost of the painting, and if you have an information about detailed information of those buildings, then we can do a kind of estimation that of a total cost if a simple repainting of color is being done for whole building or a city. So thus this helps in planning, assessment, analysis, and that is very getting importance, specifically in the cases of where we want to do resource optimizations. There are also an other applications, 3D analysis, which gives the kind of 3D viewshed analysis. So if somebody wants to know that they have to place different security cameras at a particular locations, then what is the minimum number of cameras which will be required to cover the whole area uh, by different conditions, like any area should be at least covered by one camera, or there may be the cases that the each of the area should have a two different view from different cameras. So if you want to carry out such kind of analysis, and in those cases the 3D view analysis can be done on 3 data sets. So this is just showing that at a particular location, if camera is being shown, then which all area, the green color over here is showing the area which will be falling under the or which can be viewed by the cameras. On the red color portions are the areas which is obscured and which cannot be seen from that camera locations. So this is just an example where uh, different area or locations which is falling under the view can be seen. And this is in case of 3D, so we can see the back of the building which is not getting covered. And if you are interested only in ground coverage, then in those cases also we can remove the building information, only the ground coverage informations can be created. So these are the few examples where 3D visual analysis can be maybe useful. There may be cases where the detailed level of terrain analysis can be carried out. So in such cases, if you want to find out which all area which is the rain shadow areas, and that if we identify those areas, then correspondingly the water conservation's planning can be carried out, and the corresponding things related to water conservation or water management can be done. So this is just an example where by integrating the viewshed analysis to the terrain levels can help in detailed level of planning of water management. There's an also possibility to use the shadow analysis by bringing in and seeing that which all the buildings will have a shadow effect. Like in case nowadays we are having a vertical expansion of the different cities. So as the city is growing vertically, so there will always be an impact of shadows on its neighboring buildings. So if you want to find out the cases that what will be the impact if I go for a redevelopment of one particular tower, then which all area will be having direct sunlight, and what time, and what how much solar light will be available at a different locations, and so on. So such kind of, again, applications can be built in using the shadow analysis applications. And there may be further extension of those, that based on the sunlight availability we can find out the different surface solar potentials, and that can be computed, and then we can compute the overall average solar energy which can be harnessed by any particular building. So those were the actual direct applications where we are interacting with the 3D GIS data sets. Now we'll see a few examples where we have done a few studies to do a large scale studies based on the planning. So at the city level planning, if somebody wants to carry out and they wants to see that if any particular area, if it is getting redeveloped, or which all the area which is having a potential of regrowth, then what kind of things can be done under different scenarios. So this is just an example of the Hanoi city and in Vietnam. So basically, it's a case studies which shows that there are a few restrictions. Like each of these, there's a monument over here. So within the monument, in if less than 30 meters, no building should be. The height of any building should not be more than 6 meters. Within the 30 to 50 meters, we should not have any building more than 15 meters, and so on. So these are the kind of guidelines which is being built by different agencies. So if those guidelines is being followed, and if we can see that how the city is changing vertically, so that informations can be combined to do a kind of future potential growth of a city, and again, in not in term of horizontal expansion but in term of vertical expansion. So if you're having an information of vertical expansion of area or potentials, then we can just do a prediction that where the large scale development will be possible, what height of those buildings is possible, is going to come in which areas, and so on. So this is just an example where the land use pattern techniques can be combined to do a future predictions, and the analysis can be uh, carried out to identify the potential growth areas of a particular cities. So this is the cases where scenario one is there. So it means like there is no intervention from the government. So people are just doing an usual buying and selling, and based on that, there might be a possibility of large scale development, which is possible. Then we can look for another scenarios that if instead of let this happen automatically, if we want to, if somebody intervenes and goes for large scale reconstructions, so if the reconstruction happens, then we can provide a new look or new view of a particular areas, and how the new reinstruction plan can be created. So this is just another view, or which is possibility of the same areas, if we go for a large scale redevelopment plan, and accordingly we can accommodate the different peoples in arrangement of the building and so on. So this is showing that to accommodate same amount of dwellers, what are the different possibilities, and these can be measured or can be assessed by creating a different scenarios, and that is possible in residential planning, large scale residential planning. There's also a possibility to combine the temporal domain, and that combinations whenever we do, then the disaster level preparedness can be found out. And in these cases, the 3D GIS datasets get integrated with the temporal variation of any features changes. So this is just showing the flow of water. Actually, this is animation. So this basically shows that if any if dam breach happens, then what are the temporal variations which is possible, so as the water will flow, and based on that we can generate a temporal scale, that which all area will get inundated at what time. So once we have that timelines, then we know that how much lag time is available to each of those locations, and the amount of the kind of communication we need to build it to make a people alert and so on. So this is just a cases where the small scale simulation, which can be carried out at a landscape or at a uh, city level or at a district level simulations. If we want to go for a large scale simulation within a particular cities, then we can have a detailed building structures, and that can be combined with the liquid flow models, and then this can gives the kind of cases, let's say if any tsunami happens at a particular height, then which all building will get inundated first, which all area or the building surface will get impacted, and so on. So this is coming at the location or the city level simulations that's possible. And then we can also do a simulation at the basically at the household level. So within the house, if water starts flowing, then it is not that the water will be flowing or getting filled in whole building at once. There will be a slow variations at a different time scale, at different areas may get inundated. So that also provides the by doing this such simulations, we can earmark the different location within the house, that which all area is safe in case of flooding and so on. So such kind of large scale 3D GIS and 4D modeling is possible with the help of 3D GIS. So with this, we are ending this session.